Hello, my name is Siro Genolet. I am an electromechanical engineering student at Universidad Tecnológica Nacional, Facultad Regional Paraná. This is my final project for English 2. It is about the management of spent fuel from nuclear power reactors. I chose this topic because I think that there is a lot of misunderstanding around the nuclear industry, and I hope that this work provides a better understanding of it. First of all, I would like to show you some graphics. This was the world's electricity consumption from 1974 to 2019. As you can see, the consumption has been rising almost year by year. These were the sources of that energy. Coal was the most important one, and it is currently, followed by natural gas, hydroelectric power, and nuclear power in the fourth place. Of course, burning fossil fuels leads to an increase in the amount of carbon dioxide emissions, and that poses a negative impact against the climate change, since the carbon dioxide is a greenhouse gas. As the United Nations states in their Sustainable Development Goal number 7, we need a clean, safe, and affordable source of energy for all, especially for the developing countries. Renewable energies rely on weather, so they are not capable of producing energy at any given time. So we need to combine them with baseload power plants. The baseload power plants are those that are capable of producing energy at any given time. Some examples of them are thermal power stations, hydroelectric power plants, and nuclear power plants. The nuclear energy is clean because it does not produce any carbon dioxide emissions during its operation. Also, it is safe. The nuclear industry is one of the safest industries in the world with really high safety standards, and it is reliable since it's capable of producing energy at any given time, no matter how the weather is at that time. But it has a negative side, and that side is that it produces radioactive waste. This is what this project is about, how that waste is managed. This is the way I organized the presentation. It is divided in two main parts. The first part is the nuclear fuel cycle, with some basics about fission, nuclear reactors, nuclear fuels, and spent fuel. And in the second part, and most important one, the spent fuel management in different countries. In this section, I will start with some basic explanation about the different kinds of waste and some basics about storage, and then I will talk about some countries' strategies to manage the spent fuel. The countries that they chose are France, China, Russia, the United States, and Argentina. And I will start with fission. This is fission, when an atom splits into two lighter atoms. That process is called fission. This uranium-235 atom absorbs a neutron, becomes highly unstable, and after a short period of time, it splits into two lighter atoms, in this case strontium and xenon. These two lighter atoms are called fission products, and I will mention them after. This reaction also produces neutrons between 2 and 3. It depends on the reaction. This reaction also releases great amount of energy that energy is used in the nuclear reactors to generate electricity. When we talk about a fissile nucleus, we are talking about a nucleus that can undergo fission after absorbing a slow neutron. The most used isotopes in the nuclear industry are uranium-235, almost in every reactor, and plutonium-239 in some fuels such as MOX and REMIX. Also, in the reactors that don't use plutonium in their fuel, the plutonium will appear inside the reactor during the operation of the reactor through a process called transmutation that I will mention in some time. As I told previously, in nuclear reactors, the heat released from the fission reaction is used to produce steam to rotate turbines. This part here is the reactor. Here, in this part, is where the fuel is located. This is the base of the reactor. It's made out of steel, stainless steel, and usually it is full of water. The water will cool down the reactor to ensure a safe operation and also to transport the heat from the core of the reactor to this heat exchanger where the steam will be produced. Here the hot water goes through pipes, and in this heat exchanger the cold water from this circuit is heated and it becomes steam that then will rotate the turbines to produce energy in the electric generator. This circuit here is isolated from this other circuit. There is no risk of any leak reaching this circuit or the river or a lake. Also, there is a third circuit to cool down the steam after it passes through the turbines. Okay, nuclear fuels. As I told previously, they are usually made of uranium. The most used form is the uranium dioxide. It is compressed into these pellets. These are usually 1 centimeter in diameter. These pellets are placed into these metal bars called fuel rods. Several fuel rods are arranged in fuel assemblies. These fuel assemblies usually have a 12 meters length, being just 5 meters the part where the fuel is placed. In a nuclear reactor, there are several fuel assemblies, usually more than 100 fuel assemblies. Spent fuel. When the fuel reaches the end of its cycle inside of the reactor, there have been some changes in its composition. At the beginning of the cycle, the fuel of a standard light water reactor was about, it depends on the reactor, but usually it's about 96.7% of uranium-238 and 3.3% of uranium-235. During the operation of the reactor, this will change. A part of the uranium-235 will become fission products. Also, a part of the uranium-238, through a process called transmutation, will become plutonium-239, 240, 241, and 242. Also, through transmutation, a little part of uranium-235 will become uranium-236. This is the composition of the fuel after it is removed from the reactor. The fission products are the most radioactive ones and are the ones that last the less time. They have the shortest half-life of the whole spent fuel, of the whole fuel. Okay, spent fuel management. First of all, it is important to know what are the kinds of radioactive waste. I selected 3 categories, but there are more. These are the most important ones. We have high-level waste. These are short-lived isotopes, the fission products, that are highly radioactive. These, as I told previously, are the most radioactive waste. These are the fission products, such as strontium, cesium, or iodine. Then we have intermediate level waste. These are long-lived isotopes, plutonium, uranium, and others. These are not as radioactive as the high-level waste, but they are radioactive also. These usually last for several thousands of years, while the high-level waste only need to be stored for about 100 years. Then we have low-level waste. These waste have small concentrations of actinides or fission products. The actinides are the long-lived isotopes, and this waste does not require shielding, neither to transport nor to be stored. So this waste is transported and stored in metal drums. They are stored in. It is stored in metal drums half meters under the surface, usually. This was the share of waste as of 2016. There is a mistake in this graphic, but we have 39% of very low-level waste. This is even less dangerous than the low-level waste. Then we have 53% of low-level waste, 7.7% of intermediate low-level waste, and 0.13% of high-level waste. As you can see, the amount of high-level and intermediate level waste is really small compared to the other kinds of waste. This very low-level waste is composed primarily by some tools or maybe gloves or that kind of things that could be contaminated with some radioactive material, but they do not pose a serious risk against people. Okay, the first stage after the spent fuel is removed from the reactor is the wet storage. It is in pools, usually. The pools are located inside the facility of the reactor, and here the spent fuel is stored until it decays, the fission products decays sufficiently for it to be removed from the pool. During this time, the fission products are decaying rapidly, and they release great amount of heat that need to be controlled and kept in safe levels. These pools are designed to place the spent fuel, and they have several control systems to ensure the correct operation of the pool and of course being as safe as possible. These pools do not require extra shielding against radiation, since water itself is a great shield against radiation. Usually the spent fuel is several meters under the level of water. Then, after the wet storage, we have 2 paths. The first one is to store the spent fuel in dry storage, and the second one is to reprocess the fuel. In dry storage, the fuel is placed in this kind of containers. These are usually made of concrete, and they are hollow in the inside to not all, of course, not everything is hollow in the containers, but they allow the air to go through to remove heat from the spent fuel, because it is still emitting a lot of heat that need to be controlled. These containers proportion shield against radiation and ensure keeping the geometry of the fuel. That is really important to keep the fuel safe. This could be placed inside of the facility of the reactor, or also outside of the facility of the reactor in centralized facilities. The wet storage also can be placed outside of the reactor, but every reactor has its own pool to place the fuel immediately after it is removed from the reactor. This stands for away from reactor. That is because this pool is not in a reactor's facility. This was the share of storage as of 2016. 70% of it was stored in wet storage and 30% in dry storage. Okay, now reprocessing. The reprocessing allows the recycling of spent nuclear fuels, but most importantly, it shortens the storing time for fission products. As I told previously, the fission products only need to be stored for about 100 years, while the high-level waste needs to be stored for several thousands of years. This is Thorpe in the UK. This was a reprocessing plant, now is shut down, but here the fuel was reprocessed and partitioned so it can be recycled. There are several countries that reprocess its spent fuel, and by reprocessing they can recycle some parts of the spent fuel, and that is important to save uranium and to allow the shortening the storing time. The last stage is the final disposal. The final disposal is in deep geological repositories. They are like mines, but the place needs to be carefully selected. It needs to be really dry and, of course, geologically stable. And it also needs to be far from large cities. The idea is to place the waste or the high-level waste, the waste or the spent fuel in these kind of facilities, and once the facility is full, it is closed, and that ensures that no one can get into it. Okay, so now some strategies of countries. In France, the fuel is currently being reprocessed. That allows to recycle a part of it. They produce MOX, that stand for mixed oxide fuel, and they can use it in some of their reactors. MOX is made out of fresh uranium and reprocessed fuel from reactors. It's a mix of new and recycled fuel. They store radioactive waste in and spent nuclear fuel, of course, in interim storage. The difference between radioactive waste and spent nuclear fuel is that radioactive waste is after the fuel have been reprocessed, or also is the low level and very low level waste. But when I am talking about interim storage, I am mainly talking about high level and intermediate level waste that are a product of the reprocessing process. They are aiming to reprocess their spent fuel multiple times. Currently, they can reprocess it only once. They want to achieve a fully closed fuel cycle by using breeder reactors. These kind of reactors produce more fuel than they consume, so that they can be used to burn fission products, or to transform intermediate level waste into high level waste to store it for a shorter period of time. They want to build a geological repository in the northeast of the country. The place is already selected. They think that they will open this place in 2030 to start storing radioactive waste there. In China, they are reprocessing their spent fuel, but on a non-industrial scale. So they are testing the technology and doing research on it. They are using MOX in some of their experimental reactors, but of course not in a non-industrial scale. They store spent fuel and radioactive waste in interim storage, as well as every country does. And they are aiming to be able to reprocess their spent fuel multiple times, also by using different kinds of reactors. They want to achieve a fully closed fuel cycle, by using thermal reactors. These are the normal ones. Accelerator-driven reactors. These are a new kind of reactor that only works when an accelerator is doing its work. And fast reactors. The fast reactors are the breeder reactors, also called sodium reactors. These produce more fuel than they consume. So you can put spent fuel here and transform it into fuel, into new fuel, with certain limitations, of course. It's not it would not be possible to create fuel infinitely. They want to build a geological repository, but it's not clear if they have already selected a place to do it. In Russia, they are reprocessing their spent fuel in an industrial scale. They use MOX in some of its reactors. They are storing radioactive waste and spent fuel in interim storage. They are testing remix fuel. This remix fuel is a new kind of fuel created by Russia. This fuel theoretically could be reused up to 7 times. They are testing it currently, and they are also building a centralized facility in Krasnoyarsk, almost in the center of the country, where they will build a pilot reprocessing center of reprocessing of fuel, of course, and a laboratory to develop final disposal technologies. Here in this facility, they will also build a production plant for both MOX and remix fuel, and they are aiming to be able to reprocess their spent fuel multiple times. Currently, they are not able to do that, but with remix, they will be able to do that. They want to achieve a fully closed fuel cycle, also by using breeder reactors and thermal reactors, and they want to build a geological repository, but they are far from starting building, since they don't even have selected the place to build the repository. In the United States, the fuel is not reprocessed, so they only store spent fuel in interim storage, and they are building a geological repository in Yucca Mountain in Nevada, but the project is currently stopped. It has been stopped since 2010 due to a political difference between the Nevada state government and the federal government of the United States. But they already have a geological repository in New Mexico, but that repository is only for military generated waste from the nuclear weapons program. In Argentina, we are currently storing spent fuel in interim storage inside of the facilities of our nuclear power plants in Atucha 1 and 2 and Embalse nuclear power plant. We recently deployed a new ASEC facility. ASEC stands in Spanish for Almacenamiento en Seco de Elementos Combustibles Quemados. It means basically dry storage for used fuel assemblies. This facility is being deployed in Atucha 1 nuclear power plant. It has already finished its building, and they are starting placing spent fuel in there. There is already an ASEC facility in Embalse nuclear power plant in Córdoba since the 90s, and they are doing this research to decide whether to reprocess or to dispose of the spent fuel. In Argentina, we use a different kind of reactor that does not produce the same kind of waste. We can say that is less radioactive than the waste produced from countries like the United States or France, China, or even Russia. We use natural uranium as fuel. So in the fuel that I showed previously, where the amount of uranium-235 was 3.3, in our plants we use 1% only. So at the end of the cycle, the composition is completely different. So they are doing research to decide whether to reprocess or to dispose of the spent fuel. And we are aiming to build another ASIC facility to store spent fuel from both Atucha 1 and Atucha 2. This ASIC facility will be built in the facilities of Atucha 2, but it's not clear when this project will start, since currently we have plenty of space for spent fuel. As conclusion, I would like to say that we have to know that reprocessing allows for a decrease in the amount of radioactive waste, while it helps the saves on uranium. It is important, especially for the decreasing in the amount of radioactive waste. it is the most important, I think. Also, I think that dispose of the spent fuel without being reprocessed is not a responsible policy, since it leaves a really complex issue for the future generations to solve, and every year this problem gets bigger and bigger since the nuclear power plants don't start working. So the amount of spent fuel to dispose of or to be reprocessed is getting bigger and bigger. I would like to say that engineers all around the world must work together to improve current technologies and make them safer and more accessible for developing countries. Argentina, my country, is working on a modular reactor that could be more accessible for developing countries than the standard reactors. The idea is to build a small reactor to test and validate the technology, and then build bigger and bigger reactors to be exported, especially to developing countries. Okay, that's all. These are the references to the images and graphics, and this is the bibliography that I used to this work. Thank you.